Let's factor quadratic expressions. Problem number 1. The quadratic expression is x squared minus 10x plus 24. Step 1. Make a list of factor pairs for the numeric term. The numeric term is 24, and we want to make a list of all the different ways you can multiply that equal 24 using whole numbers. 1 times 24 equals 24. 2 times 12. 3 times 8, 4 times 6 is the last factor pair that equals 24. One quick way to visualize this as the final factor pair, if we think of a number line, 1 and 24 were factor pairs, 2 and 12 were factor pairs, 3 and 8, 4 and 6, leaving us with the only value to be checked in between as 5, and we know that there is no number times 5 that equals 24. How did we make a list of factor pairs? We made a list of factor pairs by writing down all combinations of two whole numbers that multiply to give us the numeric term, in this case 24. Step 2. Find the difference or sum of each pair using the sign of the numeric term. We go back to the numeric term 24 and we look at the sign. It is a positive 24, so we are going to find the sums of all these factor pairs. Take the two numbers and just add them together. 1 plus 24 is 25, 2 plus 12, 14, 3 plus 8, 11, 4 plus 6 equals 10. Step 3. Select the factor pair that equals the absolute value of the coefficient of x. The coefficient of x is negative 10. The absolute value means to just look at the number portion of this, 10, and find the factor pair that has a sum that matches 10, which is the factor pair 4 times 6. Step 4. Write the quadratic expression in factored form such that the two numbers combine to the coefficient of x. So let's begin writing down our final answer for the factored form of our quadratic expression. What we know will be true is that we will have two binomial factors, and the first term in each binomial factor is the variable x. That's how we get the x squared back in the original quadratic expression. We also know that 4 and 6 will be the numeric terms of our binomial factors. All that's left to determine is what kind of sign we will have in between. Going back to our table with our numeric term being a positive, that means that both signs need to either be positives or both negatives, because we remember multiplying rule said when you have the same sign, you get a positive answer. We also know that these two numbers need to combine to the coefficient of x. Now we look at the complete negative 10. If these were both positive, we could not add 4 and 6 and get negative 10. But if they're both negative, now we can. Negative 4 combined with the negative 6 equals a negative 10. Also, negative 4 times negative 6, same signs, positive, equals a positive 24. We have found our binomial factors. To confirm our answer, we can always do a box model multiplication of this binomial multiplication. Combine all the terms back together, we would get x squared, negative 6x minus 4x equals negative 10x, and a positive 24. So our answer is correct. How did we write the quadratic expression in factored form? To write the quadratic expression in factor form, we set up our parentheses of our two binomial factors, we put x in the first term for each factor, and we use the factor pair that we selected from step 3 as the two numeric terms of each factor, 4 and 6 in this example. Then we finished finding the equivalent expression in factor form by finding the operation needed to ensure that these two binomial factors would multiply and give us the original quadratic expression. You are now ready to factor the quadratic expression in problem number 2.